All right, so today we're going to talk about the beginning part of functions. We've talked a lot about polynomials and stuff like that, but what makes something a function and how to find the domain, and we're going to evaluate piecewise functions algebraically, okay? That sounds like a lot, but it's really not. The domain of a function is all of the inputs that you can use. It's all of the x values. So remember, domain is x values. What is y values? Range, okay? So domain is going to be all the values of x that you can plug into the equation to get out the y values, to get out the answers. When we write our domain, we're always going to write domain in interval notation. So this is an example where they give you a domain restriction. They say use the function y equals f of x equals x squared, but only between 0 and 5. Okay, that's called a domain restriction. How would you write this inequality in interval notation? Okay, 0, 5. What goes on the outside of 0 and what goes on the outside of 5? Both of them brackets. All right, last period, some people were like, I just don't see that. If you don't see it, if you have an inequality and you don't see it, just graph it. If you were going to graph this, 0 and 5, right? What kind of dots do you have at 0 and 5? Closed and closed. And where is the x? It's in the middle. It's in between. So now, is it kind of easy to see what your domain is? Your domain would be from 0 to 5, and you have brackets because it's included. Everybody see that? This slide is very, very, very important. Your domain of any function is negative infinity to positive infinity, all real numbers, okay? We would write that as negative infinity to positive infinity, meaning I can use any x values, positive, negative, and 0. It's always negative infinity to positive infinity unless one of these three rules is broken. So here are 3 rules. This is what you have to ask yourself when you have a problem that says, what's the domain? The first rule is there a variable in the denominator? If there is a variable in the denominator, how do you figure out what the domain is? You set the denominator not equal to 0. What that means is you have something like 7 over x plus 3. Now, most of us in here can figure out what x can't be. What's the only number in the world that x could not be? 3. Not 3. Negative 3, right? Yeah. If x was negative 3, what happens? What's negative 3 plus 3? 0. Can you have 0 in a denominator? So in a case like this, your domain would be everything except for negative 3. So it'd be negative infinity to negative 3, and then negative 3 to positive infinity. That's saying you can use everything in the world except for negative 3. All right, the second rule that we have. The second rule is if there's a variable underneath the square root. Okay? If there's a variable underneath the square root, then you have to set the expression underneath the root greater than or equal to 0. Now, why? Huh?
Under the 7, the first number.
Oh, I just put x plus 3, and then I plugged in negative 3. But watch, guys. This is what this is talking about. What if you had the square root of x minus 2? Why is there a domain restriction here? Why can't I just plug in any number I want, negative, positive, or 0? What's the problem?
Because it can be imaginary.
Because if there's a negative, good. If there's a negative number underneath that square root, it becomes imaginary. It's not real anymore. So if you have an expression that is underneath a square root, you need to set it greater than or equal to 0. How come it can be equal to 0? What's the square root of 0?
0.
There you go. All right, the last rule. This is like a combo of the first two. All right, the last rule is if there's a variable underneath the square root, that's also where? In the denominator. What's the problem there? Think about what that would look like. All right, we're going to set the expression here greater than 0. Think about what this would look like. If I had 1 over the square root of x plus 5. There's two problems here, correct? What's the first problem? There's a variable in a denominator. And what's the second problem? It's underneath the square root. So that's when you have this, you have a combination. You have a combination of issues. But you have to set this expression greater than 0. Why is this one greater than, not greater than or equal to? Because the denominator can't be 0. Very good. So think about that. You have 3 rules. If the 3 rules are not broken, then your domain is negative infinity to positive infinity. So let's do some examples here. Look at letter A. Go through the rules in your head. I look at letter A. What is the problem? What rule are we breaking? 1, 2, or 3? Rule 1. There are variables in the denominator. So for letter A, you would say, okay, let's figure out what the domain is. I have to do what with the denominator? No, what do I do? I set it not equal to 0. So x squared minus x cannot be 0. In a sense here, guys, all you're doing is factoring and solving. What can I take out of x squared and x? Okay, if I take out an x, I'm left with x minus 1. Can't be 0. Now I pull it apart. So x can't be 0. And x minus 1 can't be 0. So my two numbers that x cannot be are 0 and 1. Everybody agree? So how would you tell me that? My domain would be, tell me, Marissa, negative infinity to 0. Does it include 0 or no? No, good. Union.
1 to infinity.
Okay, I agree 1 to infinity is here.
Oh, 0 to 1.
And I can use anything between 0 and 1. Good. I can use anything from negative infinity all the way up to 0. Can't use 0. I can use anything from 1 to infinity. Can't use 1. And then aren't there numbers between 0 and 1? Yeah. So I can use anything in the world except for those two numbers. If you guys don't see that, go ahead and graph it. Here's 0. Here's 1. Whoops. What are the two numbers that you can't use? 0 and 1. So you can't use 0. You can't use 1. But you can use everything else. So visually you can see, oh, I can use everything over here. I can use everything in here. And I can use everything here. I just can't use 0 or 1. Gus, question.
How do you know it's not included? Because it's not equal to it.
Yes, because if you did use 0 or 1, if you plugged it in, it would make your denominator 0. Yep, so not equal to is the same thing as like an open circle. Good question. All right, let's look at letter B. All right, B is a little different. What rule are we breaking in B? Number 2. There's a variable underneath the square root, right? So what do we do with this? 9 minus x squared, what?
Is greater than 0.
Greater than or equal to 0. Okay, how do we solve this? Square both sides, we'll take it away. So 9 minus x squared greater than or equal to 0.
Negative x squared.
Subtract 9. So negative x squared greater than or equal to negative 9. Now what? Divide by negative 1. When I divide by a negative 1, what happens? Okay, so my inequality sign flips. And now I take the square root. What goes in front of my square root?
Plus or minus.
Plus or minus 3. Now watch this, guys, for a second. If I'm going to graph this, I have negative 3, positive 3, and 0. Are negative 3 and positive 3 included?
Yeah.
Yes. Okay. My inequalities tell me which way to color. To the left. So like to the left of this one and to the left of this one, right? That looks weird, doesn't it?
Yeah.
Okay. This is a little different. So this, you guys just have to think for a second here, okay? If I look at this, let's think. If I use a number over here that's bigger than 3, say I use 4. If I plug in 4 here, what happens? What's 4 squared?
16.
16. What's 9 minus 16?
Negative 7.
Negative. Oh, okay. Nothing's going to work over there. What happens if I plug in a negative 4? What's negative 4 squared?
16.
So then what happens underneath my radical? Negative again. So it's not going to work over there either. What about if I plug in something in the middle here? What about if I plug in 0? What's 9 minus 0 squared? 9 square root of 9, that's fine. What about if I plug in negative 3? What's negative 3 squared? 9. 9 minus 9. Okay, that's fine. What about if I plug in positive 3? Same thing. So what is my domain? What can I only use here?
Negative 3 to positive.
You can only use negative 3 to positive 3, and it includes. Sometimes when you have an inequality and the square root, you need to check. You can't just go by whatever is graphed. You have to go back and check just to make sure. Oh, wait, does this satisfy? Is it going to? Because, guys, remember, when you square a negative number, it becomes what? When you square a negative, it becomes what? Positive. So sometimes that can be a little tricky. All right, let's look at C. What does C say? What rule is C breaking? The third one. This is like a double whammy. There's a square root, and it's where? In the denominator. I'm going to use an x instead of a t. So I have to take my value. Is it plus or minus? X plus 1, and I have to set it what? It's just greater than. Not greater than or equal to. Why is there a difference there? Because the denominator cannot be 0. What is going to change in your answer with the way you do this problem from the last one? You're going to use parentheses versus brackets. Good, because it doesn't include. So when I square both sides, okay, I have x plus 1 greater than 0. Subtract 1, right? So x has to be greater than negative 1. Think about what that looks like. Here's 0. Here's negative 1. What kind of a dot do I have? Open. And where do I color? To the right. So how would I say that in interval notation? Negative 1 to infinity. It does not include. Think about this. If I plug in negative 1 into my equation, what's negative 1 plus 1? 0. What's the square root of 0? 0. That would make your denominator what? 0. All right, look at the last one. Okay, go through the rules. Is there a variable in the denominator?
No.
No. Is there a variable underneath the square root? No. Is there a variable underneath the square root in the denominator?
No.
No.
So it's just negative infinity.
So what's my domain? Negative infinity to positive infinity. If none of the rules are broken, it's negative infinity to positive infinity.
You don't have to solve it.
Nope, there's nothing. All if you're just finding the domain, it's just, oh, what can I use for x? That means you can use any negative number, you can use any positive number, and you can use 0, and you'll get an answer for y. Does that make sense?
And C is different from A because it has a square root.
Yes, very good. Good. All right, let's go to the next. The last part of the notes, guys, we're going to do in section 2.7. We pick it up in 2.7 so you can cross it out. This is the first part of piecewise. Okay, you guys have seen these before, but piecewise, all it is 1, 2, or 3 different graphs. Could be lines, could be parabolas, that sort of thing. But when you graph it, you just want pieces of it. You don't want the whole thing. So remember, f of x is a fancy way of saying what? Y, okay? So they're giving you these 3 piecewise functions, these 3 pieces, and they give you something that I call, they're like parameters, guidelines, rules, something like that. These are the guidelines. When you are given a piecewise function, it tells you to evaluate at a specific variable, or a specific value. This is actually quite easy. What you do is like here in this first one. It says f of 5. So what they're saying is on a graph where the x value is 5, use one of these expressions to evaluate. Well, you figure out first where 5 falls. Look at the 3 rules. The first one says x is less than or equal to negative 2. Plug in 5 there. Is 5 less than or equal to negative 2? No, so I don't use that one. Look at the second one. Is 5 in between negative 2 and 1? No. Look at the third one. Is 5 greater than 1? Yes, so that's the expression you use to evaluate. So you guys would tell me, oh, okay, I'm going to use x plus 4. And then what do you do? What do you plug in for x? The 5. So 5 plus 4 is 9. So you would answer this as f of 5. When I plug in 5, I get out what number? 9. On a graph, what that's saying is this point would be 5, 9. That's what that's saying. All right, skip B. We'll do that in a second. Huh? I used this expression because it falls into the parameters that x is greater than or equal to 1. Look at C. First of all, you guys are like, oh, it's a fraction, guys. Let's figure out how big negative 9 over 2 is. 5 minutes, bud. How big negative 9 over 2? What is that number? It's between what? Negative 4 and negative 5. Okay, so it's negative 4.5. Right, just for your mind. So where does that fall in the expression here? Less than negative 2. It falls in the first one. Negative 9/2 is less than negative 2. So you're using this expression. 2x squared minus 3. So I'm going to use this x value. So I'm going to evaluate 2, and I have negative 9 over 2 squared minus 3. When I evaluate, guys, what do I do first? I do the exponent, I square it. So this 2 goes to the 9 and to the 2 on the bottom. So this is 2 over 1. What's negative 9 squared? 81 over, what's 2 squared? 4, good. Then I have minus 3. Now, you can multiply across 81 times 2, then divide by 4. Or you can cross cancel. 2 goes into 2 once. 2 goes into 4 twice. So I have 81 over 2. And I'm subtracting 3 from it. Well, I can change 3 into seconds. What does that become? So minus 6 over 2. What's 81 minus 6? 81 minus 6. 75. So I say f of negative 9 over 2. When I plug in x equals negative 9 over 2, I get out 75 over 2. What you guys just found was the point. Negative 9 over 2, 75 over 2. That point would be on that graph. That's what that's saying. All right, look at this one. Negative 4. Where does negative 4 fall in the rules? Negative 4, is it less than or equal to negative 2? Is it greater than 1? What is it? It's less than. So I'm going to use the top one again. So I'm going to use 2x squared minus 3. So now I'm going to say, okay, 2 times negative 4 squared minus 3. What do I do first? Square negative 4. So I get 2 times 16 minus 3. What's 2 times 16?
32.
And then 32 minus 3 is 29. So I would say f of negative 4 equals 29. Again, you found a point. Negative 4 comma 29. That's a point on a graph. Does that make sense? Okay, the last one, I skipped B. This is actually the easiest of all of them, but sometimes it's the hardest to understand. Where does 1/3 fall? Is it less than negative 2? Is it between negative 2 and 1? Or is it greater than 1? It falls between negative 2 and 1. Guys, look at what is here. The number 3. Is there anything for you to plug 1/3 into?
No.
No. Your answer is literally 3. You would answer this as f of 1/3 equals 3. You have the point 1/3 comma 3. What does that look like? Because remember, this is y, right? Y equals 3. What does y equals 3 look like on a graph?
3 up.
Okay, 3 up. It's a line, right? It's a horizontal line. So what this would look like graphically is between negative 2 and positive 1. So negative 2 and positive 1. You have this horizontal line. So the reason, why is one dot open, one's closed? Because the negative 2 is included, the one's not. Look, but what this is saying is anywhere that I gave you on the x-axis along here, whatever x value I give you to look at, what's the y value? 3, that whole area. So tomorrow what we're going to do is we're going to actually graph these things. We're going to kind of go backwards. We're going to graph these things, and then you'll be able to find out different x values. All right, does that make sense?